Hi, this is Radek. In this first video, I will introduce you to the basics of deep learning. We will briefly look at the most important parts of neural networks, what they consist of, and how you can train them without needless formulas and theories. What is deep learning? It's about learning deep or multilayer neural networks which can solve advanced problems. For example, we can process sound, image, predict stock market development, or develop artificial intelligence able to play games and so on. There are many possibilities. However, we will focus on image processing. Within image processing, we can classify the whole image or detect all objects in the scene. In our case, the object was a dog. We can train the neural network to segment all the dogs in the image. The result of segmentation is a mask. Let's look at the basic structure of neural networks. To process the image, we have to work with convolutional neural networks, which add a large number of different layers that we can use in learning. But we will get to that. The smallest unit in neural networks is a neuron. If we group several neurons together, we will have one particular layer. When we connect two or more layers, a neural network is created. In order to start training a neural network for image processing, we need three more things. First, a dataset that contains annotated images for network training. Second, the loss function, in other words the error function, that will punish the network for its mistakes. And the last one is an optimization algorithm that will adjust the connection strength of all neurons so that the network gradually learns. We will discuss all these things in more detail later in the video. The neuron. Here we show the similarity between the biological neurons we have in our brain and mathematical neurons that are the basis for artificial intelligence. Knowledge about neurons is not essential for deep learning. In practice, we usually do not work with neurons. Rather, we work with specific layers. A biological neuron has two types of tentacle-like protrusions: dendrites that receive and an axon which transmit an electrical impulse. The nucleus evaluates whether the neuron activates and transmits a pulse. Depending on the strength of the connection between neurons, it's possible to transmit a stronger or a weaker impulse, which plays a crucial role in the human brain and the neural networks. This is very similar for a mathematical neuron, in which all input pulses X are first multiplied by the strength of the connection between neurons W. Then all the weighted inputs are summed and the result is passed to the activation function. This function decides whether the neuron is activated or not. If it is activated, it will transmit a pulse in the form of a decimal number. Otherwise, it will transmit a zero value. The layer. As I have already mentioned, the layer is a specific grouping of neurons that transforms input data. The layers are divided according to the type of the transformation. Here are some of the most common layers. The first is the convolution layer, which is sensitive to the edges in a certain direction. The output of the convolution layer shows which neurons were active, marked in white color, and which were inactive, marked in black color. Next is the pooling layer. This layer reduces the resolution of its input. In our example, we got a 256 by 144 image from a 1280 by 720 image using a 5x5 pooling core. The layer performs the calculation by first dividing the image by a 5x5 grid and applying either the max or average function in each of these areas. In the case of the max function, it retains only the strongest activations of neurons. In a fully connected layer, as the name suggests, each neuron is connected with each neuron of the next layer. This layer is used to classify our activated neurons and it's placed at the end of the entire classification network. Not to forget, it's also important to get input data into the network. This is done by data layer, which reads the images from the disk and creates a batch from them. If we want to train the neural network, this layer must also produce annotations to individual images in the form of a batch. What exactly is a batch in neural networks? In general, the batch is an n-dimensional array. When we talk about batch in connection with image processing neural networks, we mean a 4-dimensional array in which we can store any number of images. Here is a small example. We want to insert 4 images into the network at the same time. The images are colored with 3 224 by 224 channels. The label or annotation batch for classification has only 2 dimensions. In the example, we have 4 annotations. It could be these values. Each number represents one species of an animal. There are still many other layers, but the ones we talked about so far will be enough for our neural network. To train a neural network, we will need a teacher. He will evaluate the error rate or loss value of the network based on its outputs and corresponding annotations. This whole approach is called supervised learning. The last puzzle piece is an optimization algorithm that takes the loss value from the loss function and starts adjusting the connection strength between the neurons or neural network weights. The loss value is smaller in the case of the same input. In other words, it tries to adjust the neural network weights to find a global error minimal from the entire dataset. The animation shows a comparison between the most well-known optimization algorithms and their speed and ability to find the global error minimal. The SGD, stochastic gradient descent optimization algorithm, is slower compared to other algorithms, but it usually has better results. The opposite of SGD is ADAM algorithm, which adapts the learning rate. It's very fast, but in some cases it may not always have the best results. And the last algorithm is RMS probe, which is the so-called middle ground between previous 2 algorithms. It is often used in TensorFlow, Keras and PyTorch frameworks. And one more tip. It's possible to combine more of these optimization algorithms during training. For example, to first use ADAM to quickly find an approximate solution and then use SGD to fine-tune. Now we are familiar with all the important parts of neural networks, and we can create one. First, we will prepare a data layer that creates 64 image batches with 28 by 28 resolution. These batches enter the first convolution layer. It has 20 convolution cores and crops the original input image to 24 by 24 resolution. It also gets the edges of all shapes in the image. This is followed by a pooling layer, which halves the resolution. The next layer can then extract more general image properties. This is followed by another pair of convolution and pooling layers. The output of this pair of layers is a 4x4 feature map. It's an ideal dimension for entering a pair of fully connected layers. Finally, there are 5 neurons at the output that identify individual classes, in our case, animal species. This was the architecture for using an already trained network. Now, let's look at what we have to add if we want to train the network. The data layer must also produce annotations for individual images. We insert these annotations as well as the output from the neural network into the loss function. Also, we must not forget to choose an optimization algorithm, but this is not written into the network architecture. This belongs to the network hyperparameters, but we will talk about that next time. And that's all for this video. If you like this video and would like to see more, subscribe to my channel. Have a nice day, see ya!